In this video, I'd like to introduce you to the concept of an array. An array is simply a way for us to group together information in a related way so that it's more efficient to work with it. So, upon conclusion of this video, you should be able to do two things. You will have built the Caesar Cipher program as an example of working with an array. And go ahead and turn that in on Schoology here, and then you can move on and complete the Introduction to Arrays video quiz. Let's go ahead and get started. Here I have two examples of arrays. Above each example I have how they would be written using C#. So the top example here would look just like a typical variable declaration. I start with the data type, so in this case I have a list of numbers and they're all integers. So it begins with int. But then I have something new. I have a set of square brackets. And this indicates that this is going to be an array of numbers. So then I'm going to specify the name of the array. So I'm going to call it numbers just for simplicity. And as usual, C# requires that I write this in Pascal case. So notice the uppercase N. But you may overlook the fact that I added an S to the end of this. So anytime we make an array, it should sound plural because it represents a collection now, not just a singular item or a singular variable. So when you create your array names, make sure that you try to make them plural. Then, if I know what values I want to store in that array, I could simply assign that array by using the assignment operator, the equal sign, and then between a pair of curly braces, I can put the elements that I want in the array. For instance, I want the value 13, 23, 33, 12, and 32. Now the computer is going to keep that list organized for us using an index. So the index of each one of these, if I were to put this in a little table, as shown here below, element 0, which is the first item in your array, refers to that first element. And then each additional element then is how far away from the original element that it is. For instance, this is 1 element away, 2 elements away, 3 elements away, 4 elements away. And because this is a zero-based system, sometimes we want to know how many total elements do we have. Well, that's sometimes referred to as its length. So even though the index here goes from 0 to 4, it has a length of 5. In other words, it has 5 elements in it. So over here, I have that noted. So let's examine the fruit example down below. So if I had an array of fruit items, I would specify fruit as the data type. Using the square brackets, I would indicate that it's an array, and I would give it a proper name. Notice how I also made this one plural. And then in between curly braces, I might have an array of objects like apple, orange, and banana. And the way that this would be visualized is index 0 refers to the apple, index 1 refers to the orange, and index 2 refers to the banana. And these are examples of one-dimensional arrays. A one-dimensional array is basically just a list like this, or a list like this. But we could also create a table of values that would have additional rows. And that's called a two-dimensional array. And for our example today, we're going to build a program using a Caesar cipher, and we're going to just focus on one-dimensional arrays. So let's go ahead and get started. This is an example of the program that we're about to build here in the rest of this tutorial, and it's called a Caesar cipher. A Caesar cipher is just an encryption technique that would scramble up a message so that it's unreadable to anyone who doesn't know how to unscramble it. So the technique here is it would take a series of letters like A, B, C, or any message for that matter, and then it requires a shift. So if I push enter here, it's going to say enter a whole number between 1 and 26. I'm going to keep it simple and say that I want to shift A, B, and C by one character. If I do that, then the A should become B, B should become C, and C should become D. So I'll push enter, and that's exactly what the Caesar cipher did. It just shifted the alphabet by one character in my character array. Now if I had a phrase like hello world and I shifted it by one, then the scrambled up version of hello world changed the H to an I, the E to an F, the L's to M's, and the O to a P, and so on. So here our message would be unreadable to anybody who doesn't know what the key is. And we can make this more complex by selecting a different shift. All right, so let's go ahead and make this program. And I'm going to open up Xamarin and create a new project. So I'm going to select the New Solution button, and then under the Other category, I'm going to select .NET Console Project, and it's going to be in C#. So I'm going to click Next, and the project name will be called Caesar Cipher. And then I'm going to click Create. To get started here, what we're going to do is we're going to delete this console.writeLine statement and replace it with some declarations. So we're going to declare a couple of arrays that this program is going to depend upon, and they're all going to be character arrays. So to begin the declaration, we have to specify the data type. So the data type is going to be char. And then to say that it's an array, we're going to add square brackets to that. So now we get to specify the name of the array. So this is going to be an array that represents the alphabet. So I'm going to call this my A to Z characters. And I'm just going to abbreviate characters as CHARS. And then we add letters of the alphabet using the assignment operator, and in between curly braces and ending with a semicolon, we can put our individual elements. Now, characters need to be contained within single quotes. So to put a character in this array, I would begin with a single quote, then I would put the character, then I end it with another matching single quote. And then I'm going to separate the elements by a comma. So there's the letter A, that would be at element 0. And then I'm going to put in B, and then I'm going to put in C. Now I'm going to fast forward this video and have the rest of the characters put in. You can do the same. So I've added the remaining characters into the alphabet here and stored them into my A to Z cars array. And I split this onto 2 lines for readability. Remember that the computer is going to ignore extra white space, so this is completely acceptable to the computer. The computer looks at a statement as ending at a semicolon, not a particular line in our file. And additionally, I've added the 2 other arrays that we're going to create. We're going to create 2 more character arrays. One's going to be called original cars, as in the original characters that are typed in as our message, and then the encrypted cars. So this is the encrypted version of the message. And then I'm going to make another variable, and I'm going to call it my key. And this is going to represent the shift that we are going to move the characters in our array. Okay, so now let's put a little bit of output to the console that describes to the user of the program what to do. So that's quite simple. We're going to say console.write, enter a message to encrypt, :space, and then we're going to store that message. So we're going to store this as a string, and I'm going to call the name of the string MSG for message. And this is going to be a console.readline method. And I'm going to convert the message to uppercase. And that's just for simplicity. So We could have this Caesar cipher be more complex and deal with punctuation and stuff like that, but I want to keep the focus of this project on just the arrays. So here we're just going to convert it to this uppercase array of characters, and the next thing is we're going to take the original characters. So this array is then going to hold, so I'm going to use the assignment operator to make it hold something. I'm going to have it hold the message, but I'm going to break up that string into a character array, like so. And then I'm going to do the same thing again for the encrypted characters. So the encrypted is going to be message to character array. So basically the original and the encrypted array is exactly the same at the beginning. And as we are going to loop through our array, we're going to change the characters depending upon whether or not they actually exist in our A to Z list. So let's put a little bit more information on the screen. Let's say that the user has to pick a number between 1 and 26 as the shift. So enter a whole number between 1 and 26, colon, space. And then let's store that as our key. And since key is a 32-bit integer, we need to convert our console read line, which is a string, into a number, into a integer. So we're just going to do that. Now let's create a for loop that's going to examine every character in our message so that we can shift it. So our for loop is going to begin with the keyword for, and now we need a control variable that is going to examine every character in our message. So I'm going to create one that's an integer data type, and I'm going to call it element just to reinforce that what we're examining are elements in an array. We're going to start with the first one, which is element 0. So at the beginning of this loop, element will have a value of 0, but that will change. Every time the loop repeats, I need to make sure that element is less than the last, the end of the array. So I'm going to say as long as element is less than original cars.length, then the loop can repeat. And every time it does repeat, I'm going to say the element is going to increase by 1. Now the for loop needs beginning and ending curly braces, and to speed things along, I'm going to add the next two variables in as well. The first variable is called alphabetical index, and what that's going to do is that's going to use a method called indexOf from the array class to examine each element in my original message. So let's say the character that I'm looking at right now is the letter A. Then the indexOf method is going to try to locate the letter A in this array and find out what its index is. In this case, the letter A is 0. So alphabetically, this is the first character. Whereas if it was looking for B, it would return a 1. If it was returning C, it would return 2, and so on. So this is alphabetically how it should be listed. Then knowing the index of each letter in the alphabet, I can then add that index value to my shift value, which I'm storing as key. So if the user up here types into the program that they want to shift our Caesar cipher by 1, then it's going to say, well, if it was the letter A, then that's element 0 plus 1, so that means that you want element 1 in the list. So my shift index then points to the letter B because that has an index of 1. So that's the shift index. Now, what if we were looking at the letter Z and our shift index was 1? Well, in the case where the shift index would go beyond the number of characters that we have, we're going to want that to go back to the beginning of the list and begin looking at the beginning of the list rather than going beyond what it could possibly store. So to wrap around to the beginning, what we have to do is basically have a little if statement. It says if the shift index is greater than or equal to 26. And then what we would do is say that the shift index minus equals 26. And the way that this would work is that let's pretend that we're shifting z by 1. Well, z is the 25th element in the array, so 25 plus 1 is 26. Then I would subtract 26 and get 0. 26 minus 26 is 0. So that would get me the letter A. So shift index now points to 0. Now it's not a good practice to have numbers like this in our program. This is a literal value. And if we changed our array to add punctuation or even the lowercase version of each number, then the array would change and I'd have to search through the code where I do this kind of stuff and adapt that as well. And in a large program, that's something that you want to avoid. So rather than putting a literal value like 26 in here, we should use a variable. And in this case, I'm going to say a to z cars dot length. This is a much more appropriate way to adapt this. And that way, if the length of our array changes, I don't have to change any code. So that's a smarter way to do this. Lastly, our loop is going to check to see if the character that we're examining is an alphabetical character that's in our A to Z characters array. And if it's not in there, we want to basically ignore it. So if it's white space or punctuation, we're just going to leave it as is. Otherwise, we're going to shift that character. So the way that we're going to write that is just with another if statement. We'll say if the alphabetical index is greater than -1. Because if it didn't find it in the list using the array index of method, it's going to return -1. So we can say that as long as it's 0 or above, we know that we found a match in the A to Z characters, and therefore it's a character. Let's go ahead and shift it. So we're going to now change the encrypted characters array at the element that we're examining. So if we say encrypted cars, and then in square brackets we put element, and then use the assignment operator, we're going to change what's in that array. And we want to change it to the A to Z index, or A to Z characters array, at the shift index. So the shift index represents the character that we want to make it into. So this will be the new character, and this refers to what the old element was over here, or that space in memory. So it's going to be overwritten. And then I just need to put a little semicolon at the end, and I'm done with the loop. Okay, so this is going to loop through every character in our original message and examine to see if it can shift, and if it can shift, it's going to overwrite that value in the encrypted characters array. So now we just basically have to print out the encrypted characters array to show our final results. So the way that I'm going to do that is I'm going to say console.writeLine, and I'm going to use an escape character. I'm going to use escape n to push down our results by 1 line, just to give it a little bit of separation. I'm going to say here is your encrypted message with a key of, and then I'm going to have to concatenate on the key value. So plus key plus, and then I'm going to add a colon onto the end and also another escape n. And then I can use the console.writeLine one more time. And strings are made up of characters, so the compiler is going to understand that if we want to print out the encrypted message or the encrypted characters array, that basically that's a string of characters. So if we just put that within our write line, it'll understand that we want to print out that particular array. Now I think what I'm going to also add in here is I'm going to add a line of dashes just to give ourselves some separation between what we entered and what we outputted. All right, now since this is a calculated value here, we've got one character right there, and then we're going to have a space and then up to 2 characters. So here's our 2 possible values of our key shift, and then here is our semicolon. So right after that, I can delete everything. And let's go ahead and try this. So we can push Control F5 on our keyboard to run this without debugging and see how it goes. All right, so I'm going to first start with ABC and see if that can shift by 1. And I get BCD. That's correct. So let's go ahead and try that again. Control F5. And I'm going to try hello world. And now it should ignore the space and the exclamation point at the end, but encrypt everything else. And here, this one worked as well. Now next, let's test to make sure that it can wrap around to the beginning of the alphabet. So if I said X, Y, Z, and I shift it by 3 characters, then I should get A, B, C. And that is correct. Okay, so the encryption is working, and now let me demonstrate how you can turn this in. So let's pretend that you can't see this solution over here. If that happens to be closed, you can get that back by simply going to the View menu, clicking Pads, and clicking Solution. And the gearbox that's next to the Solution folder, that's the purplish pink one here, you're going to click that gearbox, and then you're going to find the Open Containing folder, or on the Mac, it'll say Show in Finder. So when you open up this, you're going to basically zip up all of your files. So you're just going to highlight all this, right-click, and say Send to Compressed Zipped Folder, or you can Control-click on the Mac, and then you'll get a compressed folder. And then just change the folder name to your last name. If there's 2 people in the class with the same name, then just include your first name as well. And then you're going to upload this to Schoology. So over on Schoology, you're going to see this Caesar Cipher program assignment. You'll upload your file to here, and then you can move on to the video quiz called Introduction to Arrays Video Quiz.